Hello students, last class we have studied about the preparation of amines, both aliphatic and aromatic amines. Next we discuss about some properties. But before going properties, first I want to remember you. So last class I have asked you one question, how you prepare amine from aliphatic amine from alcohol, ethanol. So suppose how you can prepare ethylamine from ethanol. So when ethanol treated with ammonia in presence of aluminum oxide at 633 Kelvin, it forms ethylamine. But if more amount of ethyl alcohol is taken, then it gives mixture of primary, secondary and tertiary amine, that is ethylamine, diethylamine and triethylamine. Look at this equation, C2H5OH plus ammonia 633 Kelvin, OH, removal of water, NH2 plus H2O. This is primary amine, ethylamine. Then if excess of alcohol is taken, then this primary amine again reacts like that of Hofmann ammonolysis, OH, H, Al2O3 633 Kelvin give rise to whole twice NH. This is secondary amine, diethylamine, and again alcohol plus diethylamine in presence of Al2O3 633 Kelvin, OH, H, removal of water, give rise to tertiary amine. Okay, so this is tertiary amine. So after this, next come to properties of amine. So first, physical properties. Physical state. So the amines have generally unpleasant smell. The amines have generally unpleasant smell. The lower amines have some ammonia-like smell, and still higher have some fish-like smell, and aromatic amines have very unpleasant smell. Then the lower amines, that is methylamine, ethylamine, these two are gases, and still higher are liquids, and still higher are then more number of carbon atoms are generally solids at room temperature. Aromatic amine, that is ethylamine, is a liquid at room temperature, and higher members of aromatic amines are solid at room temperature. Next come to boiling point. The boiling point of amines are generally higher than that of corresponding hydrocarbons, alkanes, alkenes, alkynes, etc. because these amines can form intermolecular hydrogen bond among themselves, for which molecular association takes place, for which they have higher boiling point. With increase in the number of carbon atoms, the boiling point also increases. But in case of isomeric alcohol, the primary amine have higher boiling point than secondary amine than tertiary amine. So primary has greater than secondary than tertiary amine. Why? Because primary amine has 2 hydrogen atoms. So here the extent of hydrogen bonding in case of primary amine is more than secondary than tertiary. It has 2 hydrogen atoms in functional group, It has one hydrogen atom and it has no hydrogen atom. In this way, as the extent of hydrogen bonding is more, for isomeric amines, the primary amine has higher boiling point than secondary than tertiary. And in case of only primary amines, if this is straight chain and branch chain, then the straight chain have higher boiling point than that of branch chain isomer. Next, solubility. The lower members of amines, as they form intermolecular hydrogen bond with water, the lower members of these amines are soluble in water. With increase in the number of carbon atoms, the solubility decreases. Because the hydrophobic part increases, so the solubility decreases. And aromatic amines are generally insoluble in water. However, all these amines are soluble in organic solvents like benzene, ether, carbon tetrachloride, etc. Okay, next come to chemical properties. In chemical properties, first is basic character. Basic in nature. So, like ammonia, amines are basic in nature. So, these amines, when dissolved in water, they form a substituted ammonium ion and water. Look here. Suppose RNH2 plus water give rise to RNH3 plus OH minus. Then what is the equilibrium constant? Concentration of RNH3 plus OH minus RNH2 and water. As water is taken in large excess and the concentration of water is taken as constant, we can write H2O concentration equal to RNH3 concentration OH minus concentration by RNH2 concentration. This gives rise to another value that is called Kb. So from this, if the Kb value is higher, that means the concentration of RNH3 plus and OH minus ion both are higher. So in this way, higher the value of Kb, more is the dissociation of the base and more is its basic character. Again, we can write, we know that minus log Kb equal to pKb. So we can also write what? Higher the value of Kb, higher the value of Kb or lower the value of pKb, stronger is the base. So more is the basic, stronger is the base or more is the basic character. Okay. Next, so this is the quantitative relationship. Now how we can explain the basic character of amines. So explanation for the basic character of amines. So all aliphatic amines are generally more basic than that of ammonia. Look here, ammonia, lone pair, primary amine, secondary amine and a tertiary amine. So like ammonia, this is ammonia, primary amine, secondary amine, tertiary amine. So like ammonia, these primary, secondary and tertiary amines have also a lone pair of electron on nitrogen atom. In this way, these are basic in character. The basic character of the amines depends on two factors. One, the tendency to donate a pair of electron, and another, the tendency to receive a proton. You know Arrhenius theory, Bronsted theory and Lewis theory. According to Arrhenius theory, anything which gives OH minus in aqueous solution is known as a base. As these amines give OH minus ions with water, that's why these are base. And again, according to Bronsted theory, any substance, any species which can receive a proton, that can act as a base. As nitrogen is electronegative nature, it can receive H plus ion, hence it can behave as a base. And as they have, according to Lewis theory, as they can donate a pair of electron, they can act as a base. Similarly, as they have the lone pair of electron and they can donate it, that's why these are basic in nature. So depending on these two factors, these amines can receive H plus ion as well as they can donate the pair of electron. That's why these are basic in nature. But how can we compare the basic strength of these amines? The basic strength of these amines can be compared by three effects. What are the effects? One, inductive effect. Another, steric effect. And solvation effect or hydration effect. So, according to inductive effect, what is inductive effect? So, presence of plus I group increases the basic strength, whereas presence of minus I group decreases the basic strength. Presence of plus I group, any group it pushes electron towards nitrogen, then the electron density of nitrogen atom increases. There is in ammonia only 3 hydrogen atoms are there, but in primary amine there is an alkyl group, and this has plus I effect. This is electron donating nature, electron releasing nature. It releases electron towards nitrogen. As it releases electron towards nitrogen, the electron density of nitrogen atom increases. As a result, it can donate the pair of electron easily, as well as it can receive a H plus ion easily. So, due to plus I effect, protonation of this amine becomes easier. Hence, this is more basic than that of ammonia. Similarly, if we consider about the secondary amine, there are two plus I groups in both sides. So they possess electron towards nitrogen atom on both sides. In this way, the electron density of nitrogen atom again increases more. As the electron density increases, the receive of H plus ion or protonation becomes easier. Hence, it becomes more basic than primary amine. Similarly, if we consider our tertiary amine, there are three plus I groups. So it pushes electron towards nitrogen more. So as they pushes electron nitrogen, the electron density again nitrogen atom increases. So it can donate a pair of electron easily. Hence, tertiary amine is more basic than this. So if we consider the inductive effect, then the basic strength of this amine is tertiary amine, more basic, then secondary amine, then primary amine. But there is another effect that is called steric effect. So what is steric effect? You know, nitrogen has smaller size and this hydrogen atom has also smaller size, but this alkyl group has larger size. These are bulkier group. So in case of tertiary amine, due to presence of three bulkier group, Although the nitrogen at the electron density of nitrogen atom increases, it gives no space for protonation for receive of a proton. So, due to presence of three bulkier groups on the smaller nitrogen atom, it gives no space for receive of a proton or H plus ion. So, for which the tendency to receive H plus ion decreases, hence basic character decreases. This is called steric effect or steric hindrance. So, due to presence of bulkier group, there is some obstacle for the receive of H plus ion. That effect is called your steric hindrance or steric effect. So, this is more in case of tertiary amine and then comparatively less in case of secondary amine, then less than that of primary amine. Hence, due to steric effect, the tertiary amine is less basic than secondary than primary. So, according to steric effect, the basic strength of amine is primary greater than secondary greater than tertiary. Next, solvation effect and hydration effect. So, what is that? So, when amines are hydrated or when these are soluble in a solvent, then particularly water, when treated with water, then it receives H plus ion from water to form a substituted ammonium ion. And the substituted ammonium ion again form hydrogen bond with water. And as the extension of hydrogen bond is more, then the amine is more stable and the basic strength increases. More is the number of hydrogen bond, stronger is the base. So, as the extent of hydrogen bond in case of primary amine is more than that of secondary amine, than that of tertiary amine. So, in case of solvation effect, for solvation effect, primary amine is more basic than secondary than tertiary. Look here. So, when these amines treated with water, so this is R, N, H, and next to it receives H plus ion from water from this, and this substituted ammonium ion, they form hydrogen bond with water. So, in case of primary amine, it forms hydrogen bond with 3 molecules of water. Look here, it forms hydrogen bond with 3 molecules. Next, we consider about secondary amine. So, this is secondary amine and it forms H plus ion from water and hydrogen bond. It forms hydrogen bond with 2 molecules of water. So, there are 2 molecules of water. And another tertiary amine, this is H plus ion and it forms 1 hydrogen bond with 1 water molecule. So, there are 3 hydrogen bond with 3 water molecule, 2 hydrogen bond with 2 water molecule and 1 hydrogen. So, that the extent of hydrogen bonding in primary is more than secondary than tertiary, and this is more stable ammonium ion than this, than this. So, this is more basic than this, than this. So, solvation effect and hydration effect, the basic strength is primary, secondary and tertiary. So, according to inductive effect this one, according to steric effect this one, and according to solvent effect, the basic character varies like this. And whenever I consider about an amine, especially methylamine in aqueous medium, then combined effect of all these 3. If we consider the methylamines, then the combined effect of all these. Some cases primary is more, some cases primary is more basic, some cases tertiary is more basic. So, if we consider about the amines in aqueous solution, in case of methylamine, so the basic strength is secondary amine, more basic, this is less steric effect and medium hydrogen bonding and medium inductive effect. In this case, secondary amine is more basic than primary amine, then tertiary amine. So, this is in aqueous medium. But if we consider in non-aqueous medium, there is no steric effect because it cannot receive the H plus ion, and no solvation effect. There is no solvent. That's no solvation effect. Suppose you consider in vapor phase or in non-aqueous medium, then the basic strength varies. Tertiary amine, then secondary amine, then primary amine. This is in vapor phase or in non-aqueous medium. But in case of ethylamine in aqueous medium, the order is, in case of ethylamine, all these three factors combines of all this give rise to secondary amine, more basic, then tertiary amine. And then primary amine. So this is due to more inductive effect, more effect of inductive effect. So inductive is more applicable in case of tertiary amine, in case of ethylamine than that of methylamines. In this way, in case of ethylamine, the order is like this, and in case of methylamine in aqueous medium, the order is this, and in case of methylamine in vapor phase and non-aqueous medium, the order is like this. So, after the completion of basic nature of aliphatic amine, now let us discuss the basic nature of aromatic amines. You know, generally aromatic amines are less basic than that of ammonia. You know, in ammonia, there is a lone pair of electron on nitrogen atom which is responsible for its basic character. But in case of aniline, NH2, there is a lone pair of electron. As lone pair are in conjugation with double bond, when a lone pair is in conjugation with double bond, then it undergo resonance. So this bond move towards this, and this bond move towards this carbon atom. So we get NH2 plus, lone pair of electron having negative charge, bond like this. Again this electron pair form bond here, and this bond comes as a lone pair of electron. The different resonance structures of aniline are NH2 plus, lone pair. Okay, again this bond comes here, and NH2 plus, lone pair having negative charge. Again this one comes here. So the resonance structures of aniline NH2. So this is 1, 2, 3, 4 and 5. Among the 5 resonance structure, here we say that there is a lone pair of electron on nitrogen atom. Due to this presence of this lone pair of electron and it undergo resonance, there is no availability of lone pair of electron on nitrogen atom in structure 2, 3 and 4. So due to Plossard effect, there is the lone pair of electron come into resonance throughout this benzene nucleus. As it comes to resonance throughout this benzene nucleus, there is no availability of lone pair of electron. Hence, this aniline cannot donate the pair of electron. And another thing, due to this resonance also, the nitrogen atom get positive charge. As this nitrogen atom get positive charge, it cannot receive a proton. Protonation becomes difficult. So due to acquire of some positive charge, protonation becomes difficult, and due to absence of lone pair of electron, it also cannot donate the pair of electron easily. Hence, aniline is less basic than that of ammonia. Whereas aliphatic amines, due to plus effect, these are more basic than that of ammonia. Next come to what is the effect of substituents on the basic character of aniline. Effect of substituents on basic strength. First, presence of electron withdrawing group with withdraw electrons. It destabilizes this anilinium ion. So the presence of electron withdrawing group decreases. Presence of electron withdrawing group decreases the basic character, such as presence of electron NO2, COOH, cyanide, etc. decrease the basic strength. Presence of electron withdrawing groups, such as this group, decrease the basic strength. Then presence of electron releasing group or electron donating group, such as NH2 group, CH3 group, etc. increase the basic strength. Presence of electron withdrawing group on aniline decreases the basic strength. Presence of electron releasing or electron donating group increase the basic strength. Next, if the electron withdrawing group, next point, if the electron withdrawing group or electron releasing group, that means if the basic strength weakening effect and basic strength increasing effect, basic strength increasing effect and the basic strength decreasing effect, this effect is more effective at para position than at meta position. So the basic weakening effect and basic strengthening effect are more marked at para position than at meta position. That means if a group decreases the basic character and if it present at para position, it decreases more than at meta position. Similarly, if a group increases the basic strength, if it is present at para position, it increases more than that of meta position. Look at example. So this effect are acid basic strength weakening or basic strength increasing effect, more effective or more marked at para than meta position. For example, you know CH3 group increases. As the CH3 group increases, if it is present, CH3 group increases the basic strength. And which group increases? If it is present at para position increases more. That means CH3, para toluidine or paramethyl aniline is more basic than meta toluidine. As this group increases, it present at para position, it increases more. Hence, this is more basic than this. Similarly, nitro group decreases. If this group present at para position, it decreases more. That means, look here, this is NH2 nitro aniline and this is para nitro aniline and this is meta nitro aniline. Para nitro aniline, meta nitro. The para nitro aniline, meta nitro aniline. So this decreases. That means if it present at para, it decreases more. That means meta nitro aniline is more basic than para nitro aniline. So the basic character is paramethyl aniline or paratoluidine more than metatoluidine, and metanitro aniline is more basic than paranitro aniline. And another important point is that whatever may be the group, electron withdrawing group or electron releasing group, if it is present at ortho position, then it always decreases the basic strength than that of aniline. Not always, generally. There are some exceptional cases also, like your methoxyaniline and in hydroxyaniline. Except these two, generally, what are the groups are present at your ortho position, whether electron withdrawing group or electron releasing group present. If it is present at ortho position, then it decreases the basic strength than that of aniline. So that is called ortho effect. Ortho effect. So whatever the group is present, ortho substituted are less basic. So this is about some idea about the basic strength of aromatic amines. Now let us compare the relative basic strength of some substituted anilines. So first, toluidines with respect to aniline. So whatever may be the group present, if it is present at ortho position, it has less basic character. In this way, orthotoluidine is less basic. And CH3 group increases, and the CH3 group increases the basic character. So para and meta are more basic than that of aniline. And at this, any group which increases, it is present at para position, is more. In this way, para and toluidine more basic, then metatoluidine, then aniline, then orthotoluidine. Similarly, basic strength of nitroaniline. Nitro group generally decreases the basic strength of aniline. In this way, among the all substituted anilines, this aniline has more strength than all other. And another thing, which group, so if it decreases, then if it is present at para position, it is less basic than that of meta position. In this way, metanitroaniline is more basic than paranitro because para group decreases. And whatever group present, if present at ortho position, it is less basic. Hence, orthonitroaniline is less basic. So the basic strength of nitroaniline with respect to aniline follows the order. Next, chloroaniline. So here the chlorine has two effects. One is that is your plus R effect and minus I effect. So minus I effect decreases while plus R effect increases. But plus R effect, between plus R and minus I is more effective. As the minus I effect for chlorine is more effective than plus I, hence the chloroaniline are less basic than that of aniline. Next, so these are more basic, these are less basic than aniline, and whatever may be the group present, if it present at ortho position, this is less basic, hence chloroaniline is less basic, orthochloroaniline is less basic, and this group has plus R and minus I effect. As this group decreases, it is present at so this group decreases. So in this position, it has only what? Minus I effect. In this position, this has only minus I effect. In this position, minus I and plus R effect. So minus I effect decreases while plus R effect increases. In this way, in case of chloroaniline, parachloroaniline is more basic than metachloroaniline. Then whatever group, chloroaniline is less basic. So for chloroaniline, this is the order. Next NH2 group. So NH2 group increases because this NH2 group has two effect. Plus R, it has also plus R effect and very little minus I effect. So as it has very little minus I effect and more plus R effect. So electron releasing, in this way it is basic in nature. So, substituted aniline is more basic. In fact, whatever group present, if present ortho position, this is less basic. Hence, ortho and substituted group is less basic. Dianiline, ortho substituted aniline is less basic. And if group increases, if lossal group increases, if present at para position, it increases more. Hence, diamino and diamino group, we can say diaminobenzene. So diaminobenzene, 1, 2, diaminobenzene, para position, para diaminobenzene is more basic than diaminobenzene, then aniline, then ortho diaminobenzene. Okay, so this is something about basic character of amines, aliphatic and aromatic. Next class we will discuss about what are the different chemical properties.